System SUS.
Today, we present you a very own autonomous underwater vehicle, Jolochor.
In this video, we're going to show you that Jolochor has the potential to solve the biggest problem, flood causes our agriculture. Let's go.
Megatons of agricultural yield losses per year due to flood damages. Forecasting, dams, and inventory management system can only limit this loss to some extent. But what if we could create crops that would sustain flood submersion damages? Scientists, particularly in Asia, have been researching on this for decades, resulting in submergence tolerant rice variants. But the problem with STRs are inconsistent yield under most conditions.
The main reason behind this is the difficulty in collecting precise and real-time underwater situational data, especially in medium to high water levels. Here's where Jolochor comes in, and it will be aiding this issue.
Designed Jolochor considering all the difficulties it might face during flood. It has been equipped with the necessary modules which enables the AOV to gather real-time sensory and visual data and collect soil. IMA works with a depth sensor and DVL, allowing it to move around without any human involvement, and finally transmitting to a radio antenna at the front. The sensory hub consists of the latest technology to accurately measure turbidity, temperature, acidity, and dissolved oxygen in the water, enabling us to learn about the water quality. We've used the video ray camera in order to get the visual data and have the AOV in its autonomous navigation through 360-degree rotation. The flashlights on either side aids in getting a clear visual. Finally, for the soil collection, we've used a safely epoxy-enclosed auger drill, which will drill into the submerged soil and return back to the enclosure, taking the soil with it.
So how does Jolochor's mission look like? We launch our AOV from a boat near the designated flooded area. Jolochor's operation mainly consists of three phases. Firstly, Jolochor will provide real-time video feed regarding how the current rice variants are doing. Secondly, using its dedicated sensor hub, Jolochor will be collecting vital data from near the affected rice plants. And thirdly, our enclosed auger trip will collect soil sample and store it to finish the trip. But our work does not end there. We plan to work for the benefit of our agriculture in both short term and long term. After the AOV returns, researchers are going to have enough primary data, which will help them to make necessary genetic modification to the already existing varieties. This is going to bring upon an immediate boost in the yield and survival rate next year. In the long term, equipped with this magnificent dataset, we aim to use machine learning to predict the changes in the nature of the floods caused by climate changes and give our researchers an upper hand for the next 50 to 100 years.
STRs have particularly less yield on long and no submerged conditions because of the lack of precise situational data in researches. Jolochor, by providing these datasets, can help in finding the right germplasm, cultivars, and nursery management to find consistently yielding STRs. But additionally, due to global warming, more areas are now prone to permanent submergence. Aside from genetic research, these adequate datasets can be further used in our ML model described beforehand to battle this one out. These are the overall benefits we provide at a glance. AOVs are not being used in Bangladesh mainly because of being dependent upon manual sampling, which can be inaccurate and inadequate. Our product users will be scientists with incentive and capability of utilizing this product, but the impact can reach out to millions of farmers of Bangladesh.